This was a structure pop quiz 16, the first pop quiz of the week. So I'll solve the questions. Methanol is used in the production of many. So methanol is used in the production of many materials and a chemical compound. It is manufactured from methanol by reacting with oxygen at 300 to 400 degrees centigrade using an iron and molybdenum oxide as a catalyst. The Maxwell-Boltzmann distribution for the reaction mixture at 300 is shown. On the diagram, sketch a distribution for a higher temperature. When we increase the temperature, what will happen? The peak should decrease, and it should shift towards the right hand side. But you're not supposed to touch the x-axis at all, because if you touch the x-axis, what it means that the there is a maximum amount of energy you limit, but there is no maximum amount of energy. So at a higher temperature, the peak will decrease and shift it towards the right hand side. If they say a lower temperature, sketch a graph for at a lower temperature, then the peak will increase. So this will be the peak. But don't touch the x-axis at all, okay? Because if you touch the x-axis, it means that you make a fixed energy for the maximum. Like this is the maximum energy particle can have. But particles can have any value of a maximum energy. So the red one you're supposed to draw. Using a Maxwell-Boltzmann distribution, explain why increasing a temperature and adding a catalyst both increases the rate. So when we increase the temperature, what we simply do, we increases the number of the collagen, higher kinetic energy. That's why the rate of a reaction increases. And using a catalyst, what the catalyst will do, the catalyst will lower the activation energy. So as a result, more collagens or more particles have energy greater than activation energy. So the rate will also increase. Because if we were using a catalyst for this reaction, say this was a high temperature. So if the reaction was carried out without catalyst, so this was activation. But when we use the catalyst, so this will be activation energy. So greater proportion of the particles will have energy more than activation. That's why the rate will increase as well. An alternate method of production of a methanol using a silver catalyst at a temperature 650. So the first reaction, if you see, it was carried out around 300 to 400. But this is carried out at 650. So whenever you increase the temperature, it will always increase the cost. Like disadvantage, because high temperature, definitely you have to use more fuel. So it increases the cost of a production. So make it more expensive. And what is the advantage of using this reaction? This method is there. So because if you are using a high temperature, if you want to even compare a rate, yeah, rate will be higher, as well as if you see the product, you can also, in advantage, you can also compare the products. Like what was the product here? The product was H2O, okay? And methanol was there. But what is the product given here? The product given here is hydrogen. So hydrogen. So you can also say like hydrogen is more effective byproduct or a useful byproduct. You can also say like that. And if you say higher temperature increases the rate, it is the same reaction but different product. One is a methanol is there, which is a gas decomposes to form methanol and a hydrogen. The second reaction was a methanol reacted with oxygen to form methanol plus water, vapor, I mean. So two reactions are different. So you can compare the two reactions as well. Like the advantage here, like another advantage, if you refer, you just need a same reagent, like you need a methanol here. But here you also need oxygen for a reaction to happen. Second thing, you can also compare a byproduct. When you compare a byproduct, hydrogen is a byproduct. No, hydrogen does not harm the environment. Hydrogen is having many uses. Hydrogen in a fuel cell, it is used as a fuel. In a rocket fuel also, it can be used. So hydrogen is a very effective, very important reagent, like formation of ammonia, then forming nitrates and the fertilizer. The water vapors are produced, but you already have water in the atmosphere. So that's why you can compare the presence of the hydrogen. Or, yeah, you can mention water as a greenhouse. That also you can mention. Or you can also compare here in this part. You can also compare in this part. So many ways you can compare, but don't compare the rate. Why I'm saying don't compare the rate? If you read the question, it is already like 300 degrees centigrade and a catalyst was used there. So obviously the rate will be higher. Like there will not be too much change. Here also we just change a catalyst. So alternative method of production was we use a silver catalyst, silver as a catalyst, but at 650 degree. So obviously the rate will be higher for both reaction. For the second reaction, it will be much higher than the first one. So a comparison of a rate, even the catalyst is there, even a high temperature, almost like 300 or 400 is a high temperature. So better whenever you see such reaction, you cannot say a yield here. Why you cannot say a yield? Because it's a one-way reaction. It is irreversible reaction. So in irreversible reaction, you don't use the term yield. No, no. In irreversible reaction, you don't use the term yield. It is obvious that it's only the thing the product will be formed. Let's say if this was a reaction involved like this, reversible, and the first one, the second one is irreversible, then I can say I can compare the yield as well. Explain how infrared spectrum of a methanol and a methanol can be distinguished and state the relevant bond stretching. Then state the relevant bond stretching. So you have to memorize this certain order of it and better learn the order of these. Like example, if you compare methanol, so in a methanol, what are the bonds? These are the bonds are there. Carbon CH bonds are there. OH and OH. What about the methanol? So it will be C double bonded with O and H is there. This is methanol. So which bond can be used to distinguish here? You can use CO bond and you can use OH bond. And here we'll have C double bonded with O. Like these are the bonds which can be used to distinguish. So the OH bond stretching will be there in methanol, but we don't have this OH bond stretching in methanol. And we'll have C double bonded with O bond stretching will be there in the methanol, but it won't be there in methanol. And better learn these ranges so that you don't have to refer to a data booklet. Why bond stretching in one and not the other one? Because they are different compounds. So as they are different compounds, yeah, so how you score 2 marks, you will say in methanol, there will be a OH bond stretching absorption is there. But in methanol, there will be C double bonded with O absorption is there. And what is the OH bond stretching absorption is there? It's usually from 3,500 to 3,700 to 3,200. Usually the value, this bond stretching, it is 3,750 to 3,200. And for this is the carbonyl like C double bonded with O or a carbonyl group bond stretching is there, which is ranging usually from usually 1700 to or 1740 to 70. A small range is there, so usually 1740 to 1720. So this is 1740 to 1720. You can mention this range. And why they are different bond absorption? Because they don't have that bond. The IR graph of a bond given, your data sheet will be there in that case. Bond stretching means like which type of bonds are present. You have an methanol. In a methanol, it contain OH bond and it contains CO bond. But in methanol, it does not contain OH bond. So bond stretching in an infrared spectrum, the type of a bond which is present, the type of the bond which is present, that is called a bond stretching. Because in methanol, this OH bond, it absorbed the range from 3750 to 3200. So this bond absorption will be there in methanol. But in methanol, this bond absorption is from 1740 to 1720. So this will not be there in C because there is no C double bonded with O in methanol. So this will be missing. And same thing, there is no OH bond in methanol. So this will be missing. Is it clear? The bond absorption?